this in. And again, what I'm reading is A is equal to 1012.80. The P is 859. I'm going to put that as 00 though. The R is 3%. I'm going to say T is a variable. Oh, before I do that, N is equal to 2. It's semi-annual, means twice a year. And I can say T is a variable. And now I'm going to solve an equation. And so I'm going to solve. The equation I'm going to solve is A. Remember, an equation has a double equal sign in it. P star 1 plus R divided by N. And that's going to be raised to the NT. N star T. And what are we solving for? The variable T. Okay, for a lot of students, this is going to be a rather upsetting thing to see. Sage did not solve it, all right? Now, granted, there's ways around it, but right now, what I'm going to talk about is how I would solve it, all right? And I want to go through it just by looking at the equation. And looking at it, what I'm going to type in is, I'm going to type in the arithmetic that I'd like to perform. So someone says, what is that arithmetic like to perform? Well, looking at the equation, I know I'm trying to solve for T. So the first thing I would do is I would take A and I would divide it by P. All right, I hope that's not like totally difficult for you. All right, now granted, I'm looking at it, so A divided by P would be equal to 1 plus R over N to NT. Now what I want to do is I want to take the log of both sides then. So it's going to be log of A divided by P. Now remember, if I do this, what am I going to be seeing over here? And again, I took A, I divided it by P. When I take the log of both sides, I would see N times T, right? So I would divide by N, and I would divide by the log of 1 plus R divided by N. And this is going to solve for T. All right, now I'm doing the work. Sage is not doing the work in this one, except the arithmetic, of course. What do I get? I get that number over there. Now I want to point out, in Wells's time, they were pretty good at approximating these things, but they did have trouble getting, what we consider accurate numbers. But for the most part, 5.5 years, all right? Now someone's going to say, could you convert that to years and days? You can. So I'm going to take this number here, right? That's the number. So remember what this underscore means. It means the output of the prior input. And then I'm going to subtract 5 from it. And that's going to be the fractional part. So I got the fractional part. Then I'm going to take that. Again, this underscore means the output of the prior input. I'm going to take that and multiply it by 365 days, the number of days in a typical year. What do you get? 194 days. That's why I wrote this down over here. I would prefer to say 5 years, 194 days. Now someone, says, did Wells write that down? You know what? They were getting approximate numbers, and they had substantial round-off errors sometimes. So no, they weren't writing those exact numbers down though. But now we have digital computers. I can do a much better job. So the third example, again, I'm not saying I use Sage properly over here, but the third example, when I try to solve the equation, it had a tough time with it. And you got to keep that in mind, right? You need another way, including going to the Sage website and researching how to solve an exponential equation. I'm sure there's some routine for it, all right? Thank you.